So the first conversion we're going to do is decimal to binary. We're going to convert numbers. Decimal, if you remember, are base 10 numbers, to binary, if you remember, are base 2 numbers. So it's 10 numbers between 0 to 9 and 1s and 0s for binary. So if you remember, decimals are 10 to binary. With decimal to binary, you have to divide the numbers by 2 continually and then keep an eye on the remainder. Okay? So all you're doing is continue to divide number by 2. Keep eye on remainder. Okay, I'll give you an example once I've done the others. Okay, next one's decimal to octal. And remember, octal is 8. With octal, you continue to divide the number by 8 to keep an eye on the remainder. So if you see the pattern here, we've divided the decimal by 2 because of binary. We're dividing the decimal by 8 because of octal. Okay. And the final one is decimal to hexadecimal. With this one, we'll continue dividing the decimal by 16, keeping an eye on the remainder like we did with the others. So we're going to do an example with decimal to binary. So decimal, if you remember, is base 10 and binary is base 2. So remember what we said? We were going to keep dividing by whatever it is that it's on the right hand side. So we're going to keep dividing the number that I'm going to give you by 2, keeping an eye out for the remainder. So an example could be 72. So 72 we're going to keep dividing by the 2. 7 is 3, remainder 1, 2 into 12 is 6. Okay, so that means there's no remainders left. So if there's a remainder, you just write 1. If there's no remainder, you write 0. We'll do it again. 2, 2 into 3, remainder 1, 2 into 16, 8. So there's no remainder again, so we write 0. We do it again. 2 into 18, 9. Is there a reminder? No. Do it again. 2 into 9, 4. But then there's 1 remainder, so 4 times 2 is 8, plus remainder 1 is 9, so 1. Divided by 4 is 2. Is there anything left? No. 0. Again. 2 into 2, 1. Is there anything left? No. Again. 2 into 1, no. So you write 0. Something left? Yes, because it's 0.5. Okay, so what you then do is you realize that you have your zeros and you have your ones, so you have to write it out. But the thing you have to remember is this is the most significant number. And this is the least significant number. What does all this mean? So that means you write this one first and this one last. So you're going to write 1000. And then to remind yourself, this is the least significant number. And when I say number, I mean bit, okay? Okay. And this is the most significant bit. So what does all of this mean to us? So the answer, if you see 72 to the 10 is 100100. All of this will make sense by the time we get to the end of the video, I assure you. Okay, next example, decimal to octal. So here we have a decimal, base 10, to octal, base 8. And then if you remember, decimals between 0 to 9, and octal is between 0 to 7. Okay, so if I give you an example of 141 base 10. And I'm asking you, what is it to base 8? In an octal representation, you'll do 141 divided by 8. Because remember, every time that we're given something, we have to divide by what's on the right in the base. So it's 17 with the remainder 5. And then 8 again is 2 with remainder 1. And then if I wrote 8 again, it's 0 with the remainder 2. Okay, so if you remember from before, this is the most significant bit and least significant bit. So when we rewrite it, we start from the bottom and work up. So we write 215 to the 8. So 141 to base 10 can be converted to 215 to base 8. Never forget that the remainders are only between 0 and 7, because it just has to always be between 0 and 7 if it's for octal. One to base 10 to something to base 16. So you would do 141 divided by 16 and get 8, remainder 3. If you did it again, you would get 0, remainder 5. And if you remember from before, when we talked about with the hexadecimals, when we said you had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then when you got to 10, 11, 12, 13, 14, 15, you started from the number 10, you started with the alphabet. So you had A, B, C, D, E, and F. So because this is number 13, we have to remember 13 is D. So then we write 13 as D and 5. So remember, this is the most significant bit and this is the least significant bit. So we're going to write 5D. We're not going to write 513. Okay? So the answer here is 5D. Easy peasy! I know you could be anywhere in the world right now, and I thank you for watching this video, and I'll see you in the next one.